Real life problem on volume. Differentiation problem 3. A cuboid box with a lid has a dimensions 3x centimeters by x centimeters by y centimeter. It is made using a total of 450 centimeters squared of wood. That will be surface area. Show that the volume of the box can be expressed as V equals 675x minus 9x cubed over 4, and use calculus to find the maximum volume. Okay, so we've got the cuboid here. The length is x and the width is 3x and the height is y. And we need to find the volume for the cuboid. Volume, call that V, will be equal to V equals x times 3x times y, because this is x, that's 3x, and that's y. That equals 3x squared y. We also need to find the surface area. So SA equals, now the surface area of that is x times y. And we got two of them, so that would be 2xy. The surface area of this one is 3x times y. Again, we got two of those, so that would be plus 6xy, because that's 3x times y times 2, that would be 6xy. Plus, we need the surface area of the top and the bottom, that would be 3x times x. 3x times x is 3x squared, times 2 will be 6x squared. And if we add them together, so that would be 2xy plus 6xy would be 8xy plus 6x squared. And that equal to the total surface area, which is 450. The best thing to do here is to make y the subject. So we've got 8xy plus 6x squared equals 450. Y will be equal to 450 minus 6x squared divided by 8x. Now 2 is a common factor at the top. If I take 2 out, I get 2 to 5 minus 3x squared over 8x. I can see that 2 cancels there. So 2 there, 1, and 2 there, 4. So there's 4 left. So y equals 2 to 5 minus 3x squared over 4x. What I'm going to do is substitute y into here. So v equals 3x squared, open bracket, 2 to 5 minus 3x squared over 4. Therefore, v equals over 4x, by the way. The x here cancel the x. So you got 1 there. 3x times 2 to 5 will be 675x minus 3x times 3x squared, 9x cubed over 4. So that's the volume we're supposed to prove. In the question, it says we need to show that expression, and we've done that. The next part of the calculation is to find a maximum volume. We have an expression for volume, and I'm going to write this expression as V equals 675x over 4 minus 9 over 4x cubed. Now, this expression is written in the form of V equals x to the power of n. V depends on x, so V is a function of x. Therefore, we can then write the derivative of that. So we've got V equals x to the power of n, and the V, the x, will be equal to nx to power n minus 1. And that's what the process we use to find the gradient. Why do we need to find the gradient? If you're finding a maximum value, what that meant is you would have to have the top of the maximum value or the minimum, the bottom of the minimum value. And that is called, in this case, the v, the x equal to 0. If you have the maximum value, that will be 0 there. If you have the minimum value, it will be 0 there as well. So because you always be at the top or at the bottom. Now, if you do second derivative and your second derivative is negative, then that will be the 2v the x squared, and if it's less than 0, that's a negative gradient. For second derivative, then the gradient is a maximum. If it was positive, if that's greater than 0, then that will be a minimum. So that will be minimum, in this case, volume, because we're having a volume problem, and that will be maximum volume. So we're trying to find the x value where that is at the top. At that top, the v, the x is 0. So we need to find the x value to find the gradient, if that was maximum, or even though if it was minimum. So let's differentiate that. This is to the power of 1. So the v, the x, will be equal to 1 times 675 over 4. That would be 675 over 4. X to the power 1 minus 1, 0. We know that anything to the power of 0 equals 1. Then minus 3 times 9 over 4. That would be 27 over 4. X to the power 3 minus 1, 2. But let's set this to 0 first, because at the turning point or at the stationary point, the v dx equal to 0. So therefore we have, well, x to the power 0 is 1, so we got 675 over 4 equals, by moving that to the right, 27 x squared over 4. In this case, the 4 will cancel out, and therefore x squared equals 675 over 27, and that equals 25. X will be equal to plus or minus root 25, and that equals plus or minus 5. But we cannot have a negative length, so x is going to be equal to 5. Now we need to find the 2v the x squared, and that will be equal to, so we're differentiating that now. That will be 0 times the constant here, so that will be 0, minus 2 times 27 over 4, that will be 2 times 27 over 4, x to the power 2 minus 1, 1. Therefore, the 2v, the x squared, will be equal to minus 2 cancels 1, 1. So that will be 2 there. So that will be 27 over 2x. So when x is 5, because that's the point we want to show, you can see it's negative anyway. So when x is 5, it's going to be negative. So therefore, the 2v, the x squared, when x equals to 5, will be equal to minus 27 times 5 over 2, and that equals minus 135. The second derivative is negative, so therefore it's a maximum, not minimum, maximum, because it's negative. If it was positive, it would be a minimum. So therefore, when x equals to 5, the volume max will be equal to 675, that one here, multiplied by 5 minus 5 cube over 4. So that's what we're doing now. We're finding the volume. And when you plug that into your calculator, V max will be 562.5 centimeter cube. That's the maximum volume.